Good evening, class. Today I'm doing my discussion post over 7-14. It says draw the shear and moment diagrams for the beam. Here we can see the beam. It's got a distributed load of 8 kilonewtons per meter over 1.5 meters. And then it's got a point load here of 6 kilonewtons 3 meters away from point A. So the first step that I'm going to do is draw the free body diagram of the beam with the forces. So here, this will give me my reaction forces of AY, AX, and then MA, the reaction force stopping it, since this is fixed and not on any sort of rotational axis. I also have my 6 kilonewtons here all the way to the side. Finding my sum of the forces in the x direction gives me 0, of course, because there's only this AX, nothing else. Our sum of forces in the y direction is going to be our positive AY minus the 12 kilonewtons here, minus the 6 kilonewtons for the point load. To get this 12 kilonewtons here for the distributed load as a point load, I simply took the 8 kilonewtons over 1.5 meters, so that's 8 times 1.5, which gave me 12. That'll result in AY equaling 18 kilonewtons. Then I'll sum the moments on point A. This will give me that negative 12 kilonewtons, 0.75 meters away for the moment arm, minus, because this is going down, causing a clockwise direction, minus 6 for 3 meters. This will give me a moment on A of 27 kilonewtons per meter. Continuing on, I split it into two parts. Here I've got the left side with the distributed load, and here I've got the right side with just that point load. Let's start on the left. So here, I went ahead and redrew it, and since I know that that distributed load is 8 kilonewtons per meter, I pretty much put 8 kilonewtons and then x for my meters, so it's an arbitrary amount of meters. And I split my length from my cut up into two sections right in half, so whatever length x divided by 2 for each side. Then, since I did cut my beam, I have the shear force here and the reaction moment there. First thing I did was sum up my forces in the y direction. It's going to give me AY minus an 8x minus V1. Solving for V1, I'll get negative 8x plus AY. Substituting in AY, I get V1 equals negative 8x plus 18. Now, I want to take that V and find out when the shear is 0, or what the shear is at 0, when x equals 0. So I'll plug 0 in for the x, and at 0, that should give me a shear of 18. I'll do the same for 1.5 because that's where the distributed load stops. So I'll take 1.5 as my x, which will result in 6. And up here I've recorded that as in the beginning at 0, where x is 0, my shear is 18, and all the way here at 1.5, my shear will go down to 6. Next, I took the sum of moments at the cut and set them equal to 0. So it'll give me that moment plus an 8x here with a moment arm of x over 2, since it's halfway in between, plus the moment arm A minus AY times x. This will solve for M1 to be negative 4x squared plus 18x minus that 27. If I plug 0 in for my x, M1 will equal negative 27. And if I plug 1.5 in again for my x, M1 will equal negative 9. We can go up here and see negative 27 on our moment. And for x equals 1.5, it goes down to negative 9. Or up to negative 9, I should say. Next, I solve for the right side of my cut. This just has our shear force here, as well as our M2 moment. The length of this beam was 1.5 meters, and there was just one load on it of 6 kilonewtons at the very end. When summing forces in the y direction, that gave me my positive V2 minus 6 kilonewtons is equal to 0. So V2 is equal to 6 kilonewtons, which works out pretty well because, let's see, I believe I have V, yes, my V at 1.5 over here equals 6 as well. So when at the cut, when my V is equal to the same, that's a good sign. Next, I'll sum up the moments at the cut. This will give me M2, and then minus in the negative direction, a 6 with a moment arm of 1.5 meters equals 0. Moving this to the other side, I get M2 equals 6 times 1.5. M2 equals 9 kilonewtons per meter. And since this is just a straight line on our shear diagram here, I know it'll be a linear straight line down on my moment diagram. And since this had a slope here, I knew that was going to be a parabolic slope here. This solves for all my forces and moments and completes my shear and moment diagrams. Thanks for watching.